confronted a rare or beautiful or strange object, look at it closely, absorb what it does for them, and really begin to learn how to look. I think that's so important, not only in museums, and we don't only encourage people to look, which visitors could see glass in all its manifestations, from the most ancient glass on the planet to glass being made by industry today. What the collection sets out to do.
My name's Caitlin. I'm going to make a glass dog this morning.
Glass dog?
And we're starting out here with solid rods of glass and then a big open flame.
We're going to make a glass dog.
The glass I'm going to use here is called borosilicate glass because it has boron as one of its ingredients. And that means it's a strong glass. We call it hard glass as compared to standard window glass, which we call soft glass. And that means that this glass is extra strong and it melts at a high temperature compared to other types of glass. So I'm going to heat this up to about 3,000 degrees Fahrenheit. You will see a bright glare coming from the glass. That's called soda flare. And it comes from another ingredient in the glass called soda ash. The soda flare isn't so bright to be damaging to our vision, but it is a little hard to see through. It's not only bright, it's kind of cloudy as well. And so if you'd like, take a look through the filter that's on the front of the booth while I'm working. That is called a didymium filter. Didymium is made of rare earth elements, and it filters out the soda flare so that we can see the surface of that glass a little. We're going to start with a kind of peanut shape here. Stretch that out a little bit to make the dog's body. Now while I'm inside the booth, I won't actually be able to hear you very well if you have questions, but if you do think of questions, you can save them for me. I will be coming out of the and that's because heat doesn't travel through glass very fast. And so the part I'm holding on to is actually still room temperature. Now I heat that glass up until it's very soft, and then I can stretch it into the shape that I want. By alternating between heating and cooling it, I can get it to move, and then later...
In your home. So it is very stable. It requires a good deal of force to break it. When we supply that force, it breaks in unpredictable sizes and shapes, but almost always it's going to be sharp glass. So around this glass you want to be extra careful not to cut yourself because potentially it is very sharp. Now the weird thing about this glass is prior to the 1930s, this is exactly the same type of glass that was used in the early automobile windshields.
He told me that he wants to make a nice big ice cream bowl for everybody. So to get started with his ice cream bowl, what he's doing is he's gathered up some clear glass from the furnace. Now this is clear glass. It has that beautiful yellowy golden glow to it because of the heat. 2100 degrees Fahrenheit, right out of our furnace. It's about the same temperature as molten lava from a volcano. So it's pretty hot. Now we're shaping the glass up. We want it to be nice and smooth and even for the actual blowing process. And when Dan has everything shaped just how he wants it, we'll see him blow through the blowpipe. He'll trap the pressure in there with his thumb, and that pressure will have nowhere to go but expand through the hot glass. And so you'll come to see his breath just emerge from the pipe. Okay, here he goes. So he traps the pressure in there, and then watch the glass. There it goes. That was glass blowing. What do you think? Now from here we only have enough material to make like maybe a small ice cream dish that would only hold a single scoop. of vanilla ice cream, or maybe a small drinking glass. Well, we couldn't make something large. We couldn't make, you know, a nice big water pitcher. We couldn't make a nice big fruit bowl. We don't have enough glass. And so what we're going to do is we're going to gather more material from our furnace right on top of it. And this is how we build up size. We build it up in layers. Well, we call those layers gathers. We have our first gather. Stick, you just gather it out. Well, if you stop turning the honey dipper, the honey drips, right? And the same thing with our glass. They're very similar in consistency. Obviously, our glasses. And we're going to go back and forth between inflating the glass and shaping it with different tools. This metal tool that we're using right there, those are called jacks. And we're using the jacks to squeeze a small constriction right off the end of the blowpipe. That small constriction, that'll be the lip of our vessel. And more importantly, that'll be where we remove the piece from the blowpipe later on. Everything that we make, we have to be able to break free from the blowpipe. It doesn't matter if it's a vase or a bowl, a water pitcher. On the last show Dan and I did, we made a turtle. And even that turtle had a small constriction so that we could break it off of the blowpipe. Alright, it's time to add a foot. We could just press on the bottom and flatten it, and the bowl would stand on that, but we want to add a pedestal. We want to add a foot. We're going to drip some glass right on there. We aren't going to drip this glass. You'll see why we're always turning. Because as soon as I stop turning, see how gravity just pulls it? And then Dan catches it with the bowl. He shapes it up. Now he has a graphite paddle there, he just kind of pressed on it. And then he'll get in there with some tweezers and actually pinch the glass. They have a really cool, kind of a twisty wave pattern. I just took a little bit of the excess glass from the pipe and I snipped it into the bucket. That's our recycling bucket. All of the clear glass that ends up in that bucket, we'll recycle that. We'll just literally shovel it right back into the furnace and remelt it. Now the leftover glass that's on the pipe right here, we're going to make, we call it a punty. And what we'll do is we'll attach the punty to the very bottom, attach it to the foot. We'll break the bowl free from the blowpipe at that constriction we made earlier on. And this punty, this is our handle. This allows us to hold on to the bottom and work on the top. Now that's a wet little file blade there. We'll just scratch the glass. And it's amazing. It doesn't take much, just a nice tap. See how that just breaks right off? Now we've transferred the piece. There you go. Now this is very traditional. You work on one half of a piece, and then you flip it over and work on the other half. Glass has been made by hand like this for a long time. In 1903, however, a man named Michael Owens, he developed the Owens bottle machine, light reflective quality. You know, when light hits a piece of wood, it just kind of shines on the piece of wood. Same thing with a metal sculpture. But light really passes through glass, and it makes great